Welcome back. This is Mr. Greenstein's Geometry, and we're talking about Chapter 9.7, the Law of Sines and the Law of Cosines. We just covered in Part 2 the Law of Sines. This Part 3 out of 3, is going to be talking about the Law of Cosines. So the Law of Sines was perfect for a couple of these scenarios. One is side-side angle. Another is angle, angle, side, and then finally angle, side, angle. But what happens if you have a triangle that has 3 sides, but we don't know any of the angles? Or we have a triangle that has 2 sides and the included angle, side. Well, the way that we can solve that problem, because we can't use the law of sines in these cases, is the law of cosines. Now let's see what that actually looks like. It's kind of a nasty formula, but we're going to try to break this down. It says that in any triangle, the side lengths and one angle follow the formula of c squared equals a squared plus b squared minus 2ab cosine of c. If we were to write this out, I would like to write it out in a way that I can remember it. So one way that I can remember it is that, say that we want to find side C. So we'll put side C way over here on the left-hand side, and we'll put the angle C on the right-hand side, like bookends. They're going to be holding up this whole equation. Then on the left-hand side, I'm going to use this side C, and I'm going to make Pythagorean theorem. So c squared equals a squared plus b squared. And for the angle C on the right-hand side, I'm going to put the put cosine in front of it, so that'll help me remember cosine. And then the part that we're going to have to remember is the in-between part, which is minus 2ab. So we have c squared equals a squared plus b squared minus 2ab cosine c. So we'll try to remember this by looking at our bookends, which are the c squared and the c on both sides. Then I've got Pythagorean theorem, which is right here. And I have my cosine for my c. And then I have the part that I'm going to have to remember in the middle. So that is this part right here, minus 2ab. So that's the law of cosines. Now let's actually use that, and let's go past a couple of these, to solve a problem. And one of the problems that we can solve is side, angle, side, where we have the side, and the included angle, and we want to find out the other angles. Well, if we use the law of sines, it needs an angle and an opposite side to create a ratio. Well, if you look here, every time we go from a side to an opposite angle, or angle and opposite side, we can't match up anything that has numbers in it, because angle A and angle C are missing, and so is side B. So let's use this formula, the law of cosines. I want to find the length of B, so I'm going to use this formula and plug everything in. Let's do that. We're going to have b squared minus 2a squared, so a is 11, so we're going to have that squared, plus c squared, which is 14, that's the opposite of the angle C, minus 2 times a times c times the cosine of the angle B, which is 34. And if we calculate all of this out, then we end up with B being equal to 7.85. So now we have side B, and we want to calculate the other angles. To calculate the other angles C and A, we can go back to the law of sines. So we don't have to use this long formula down here. We can use these ratios up here. So to calculate the angle A, I'm going to use this angle here, 34, and the side B, which is 7.85, as my ratio, and then calculate A. So I'm going to say the sine of 34 divided by the side 7.85, that's little b, is equal to the sine of A over the side A, which is 11. And then I calculate all of this out, and I get an angle for A is going to be equal to 51.57 degrees. To calculate angle C, all I have to do is just subtract out the other two angles. So I have 180 minus 34 minus 51.57. And I come up with angle C being 94.43. So that's how I would solve a side angle side scenario, calculating first the side B and then using the law of sines and the fact that I have triangle sum theorem, just subtracting out the other angles. Now let's look at another scenario, which is side, side, side. Say I have all three sides, but I have none of the angles. Well, in this particular case, I need to calculate one of the angles, and here I have all three sides and an angle, and I'm going to use the same formula. So I'm going to find the value of angle B. And the way that I'm going to do that is I'm going to plug it into this formula. So if I do that, B squared is going to be 27 squared equals A squared is going to be 12, that's 12 squared, plus C squared, which is 20 squared, minus 2 times A, which is going to be 12, times C, which is 20, times the cosine of the angle that I want to find, which is B. When I calculate all of this out and move things around, I'm going to find that B is equal to the inverse cosine of a very large equation. It's going to be 27 squared minus 12 squared minus 20 squared all over negative 2 times 12 times 20. And when you plug all that into your calculator, you get the angle B. And the angle B is going to be 112 degrees, 0.67. So now I have one angle. And now that I have this angle B, and I know what the side B is, now I can use my ratios. So I'm going to plug it into a law of sine, and I'm going to say the sine of the angle B, which is 112.67, divided by the side B, which is 27, is equal to, well, it depends on what angle I want to find. I want to find angle A first, so I'm going to say the sine of A, divided by side A, which is 12. And when I work that out, I end up with A equal to 24.21 degrees. To find angle C, well, now that we know both A and B, so we'll just take 180 and subtract out 112.67 and subtract out 24.21, and we end up with C being 43.12 degrees. So now we have all three sides and all three angles, and we solved it using the law of cosines. We will discuss more of this when we get to our next class period.